Okay. Algebra 1, Module 4, Lesson 18, cubic, or graphing cubic, square root, and cube root functions. Number 1 says, describe the relationship between the graphs y equals x squared and y equals the square root of x. How are they alike? So let's talk about how are they alike. Would it do well for us to graph them right quick so we can look at it? Let's try that. So, if this is 0, 1, 2, 4, let's not do 2, 4, and 6 because those are going to get really big. Let's do 1, 2, 3. We'll do -1, -2, and -3. So when let's do x squared in this green color. So x squared. When x is 0, what is y?
0.
Y is 0. When x is 1, y is
1.
Let's do some numbers up through here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So when x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. Now, when x is -1, what is y? Jordan? Wake up, Jordan. When x is -1, y is what? 1. When x is -2, y is 4. And when it's -3, it is still 9, and I can't mark it there. But it's going to be, it will be symmetrical, but it's going to draw it like okay. Now, if we do square root, what is it? If we do square root of 0 is what? 0. So let's do that in a different color so we can see it here. We'll do Christmas colors. 0, 0. What's the square root of 1?
1.
What's the square root of 2? Square root of 2? 1.4. What's the square root of 3?
1.7320.
So it's going to look like this because I cannot do a negative square root. You cannot do a negative square root. Why? Why? That is the question. You cannot square root a negative. Right now you can't. You will later on. If you square a number, it will not come out as a negative, correct? If you have a negative and you square it, it comes a positive. You see that? That's the reason why you cannot do that. So it says describe this relationship. So the square root is what? It's half of a parabola, right? It would be half of a parabola, but it would also be what? Reflected, right? See that? Now, how else can we talk about these? Well, first of all, how are they alike? How are they alike? Well, I'm trying to think. I can't think of how they're alike. Let's talk about how they are different. The domain of x squared is all real numbers, right? We can do anything. But the domain of the square root of x is what? X has to be greater than or equal to 0. We can't do negatives there. You see that? So that's how they're different. Oh, here's a way that they're alike. The range for both is what? X greater than or equal to 0. X. Your y is going to be greater than or equal to 0, right? You're never going to have a negative there. You see that? That's how they're alike. Alike, this is how they're different. Okay? Now, number 2 says, describe the relationship between the graphs y equals x cubed and y equals the cube root of x. Now, we just said that you can't have negatives inside a square root, right? Is this a square root? No.
Jordan.
So, can we have a negative inside this? Why can we? Everybody understand that? Cube root of a negative 27. Can we do that? It's a negative 3. How? Because a negative 3 times a negative 3 is positive 9. Times a negative 3 is negative 27. So we can cube root negatives. Okay? You can cube root negatives. So that tells us, what about these? That we can do both the domains as all real numbers for both of them. Okay? The domains for both of those are going to be all real numbers. Well, if the domain is all real numbers, what's the range going to be? All real numbers as well. Correct. All real numbers. Let's try and graph it right here to see. So if I said this is 1, 8, -1, and 8. What is the cube root? Or let's do. I did those exactly opposite. I'm sorry. Let me do those backwards. Let me do 8, -2, 2, and -8. What is 0 cubed? 0. What is 1 cubed? What is 2 cubed? 8. What is -1 cubed? Shut up, Michael. What is -1 cubed? -1. What's -2 cubed? -8. So here we have this little curve right here. And it's going to be much more exaggerated. It's going to look more like this because it's exponential, right? But because my scales are not the same, they're turning a little bit slower, okay? Now, if we did the cube root, what's the cube root of 0? Cube root of 0 is 0. What's the cube root of 1? What's the cube root of 2? Cube root of 2. All right. What's the cube root of -1? What's the cube root of -2? Yep. So that's what that's going to look like. Now, remember, let's go to page 2. Remember how we talked about the quadratic. Oh, that's an A. That's not what I wanted. Quadratic. Something squared, right? We're going to look something like that. Okay? With a vertex. Y-intercept. This one doesn't cross the x, so there's not going to be, you can't solve it. Now, with a cube root, or a cubic, how do we talk about, first of all, -infinity, what happens? How's the end behavior here? On this quadratic, as x approaches -infinity, y approaches what? Positive infinity. As it approaches, x approaches positive infinity, what does y approach? Are you looking at the same thing I'm looking at? Are you on page 2? As x approaches infinity, what does y approach? Infinity. Because as it goes this way, it continues going up. As it's going to the left to -infinity, it's going up. Now, With a cubic, this is what's fun about cubits. I told you since there's two, or since it's a square or a quadratic, how many answers are they? Two. There's normally two. How many do you think there's going to be with a cubic? Three. Ooh. Because it's going to look something like this. Okay? How many times does that cross the x-axis? 1, 2, 3. You're going to get 3 answers. Now, every cubic is going to look like this. Quadratics, same direction for the end behaviors, right? Cubic is going to look different. They're always going to be pointing in the opposite end behaviors. So, as x approaches negative infinity, what does y do? Negative infinity. As x approaches positive infinity, what does y do? Positive infinity. They're opposites. Okay? Quadratics, they're the same. Cubits, they're going to be opposites.